If you're manually updating route tables every time your network changes, you're doing it wrong. And I've seen this single mistake cause 4-hour outages at companies running production workloads.
4 hours? Just from routing configuration?
Exactly. Because when you use static routing with AWS Site-to-Site VPN, you become the single point of failure. Today I'm going to show you why dynamic routing with BGP changes everything, and how route propagation automates what most people do manually.
Alright, I'm definitely paying attention now.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and with me today is my favorite curious engineer.
Hey everyone, ready to learn about VPN routing today?
We're diving deep into static versus dynamic routing for site-to-site VPN, and specifically how route propagation behavior differs between them.
So let me set the scene here. I've got a site-to-site VPN connecting my on-premises data center to my AWS VPC. I configured static routes pointing to my on-prem CIDR blocks, and it works. Why would I change anything?
Here's the problem. Let's say your on-prem network is 10.0.0.0 out of 16 today. You add a new office with 10.1.0.0 out of 16. With static routing, you have to manually add that route to your VPC route table. Forget to do it? That new office can't reach AWS. Now multiply that by 50 route tables across 10 VPCs.
Oh no, that sounds like a recipe for human error.
It absolutely is. And here's the technical reality. With static routing, AWS has no way to learn about your network topology. You're essentially telling AWS, quote, "Trust me, send traffic for these specific CIDR blocks through this VPN connection," end quote. There's no verification, no automatic updates.
Okay, so what's the alternative?
Dynamic routing using Border Gateway Protocol, or BGP. First, you need to create a virtual private gateway, or VGW, and attach it to your VPC. Then, when you create the site-to-site VPN connection itself, you choose dynamic routing, which enables BGP. Your VGW then speaks BGP with your customer gateway device, and they exchange route advertisements automatically.
Wait, so my on-prem router tells AWS what networks exist behind it?
Exactly right. Let me use an analogy. Think of static routing like giving someone written directions to your house. If you move, those directions are useless until you write new ones. Dynamic routing with BGP is like sharing your live GPS location. Your friends always know where you are, even if you move.
That makes sense. But I want to make sure the analogy holds technically. Is BGP really sharing live updates?
Great question. And yes, it holds up. BGP maintains a persistent TCP session on port 179 between your customer gateway and the VGW. When your on-prem network changes, your router sends a BGP update message advertising the new prefix. AWS receives it and can automatically update routing. The key word there is "can" because this is where route propagation comes in.
Route propagation. I've seen that checkbox in the console, but honestly never understood what it does.
This is crucial. Route propagation is a setting on your VPC route table that determines whether routes learned via BGP from your VGW are automatically added to that route table. You find it in the VPC console under Route Tables. Then select your route table and look for the Route Propagation tab.
So even if I'm using dynamic routing with BGP, I still need to enable route propagation?
Exactly. This trips people up constantly. You can have BGP working perfectly, your VGW learning all your on-prem routes, but if route propagation is disabled on your route table, those routes just sit there unused. Your EC2 instances won't know how to reach on-prem because the route table they're using doesn't have the routes.
Let me make sure I understand. With static routing, I manually add routes like 10.0.0.0 out of 16 pointing to my VGW. With dynamic routing, BGP learns those routes, but I need route propagation enabled for them to actually appear in my route table.
Perfect summary. And here's a specific technical detail. When you enable route propagation, you'll see those BGP learned routes appear in your route table with a target of your VGW ID, something like VGW1234 ABCT. In the console, there's a propagated column that shows yes for these routes, versus no for routes you added manually. That's how you can tell at a glance which routes came from BGP versus your own configuration.
What about the ASN numbers I keep seeing mentioned? My on-prem team asked what ASN to use.
Great question. ASN stands for Autonomous System Number. It's how BGP identifies different networks. AWS VGWs use ASN 64512 by default, but you have options when creating the VGW. You can specify a private ASN from the 16-bit range, which is 64,512 through 65,534, or from the 32-bit private ASN range, which is 4,200,000,000 through 4,294,967,294. If your organization owns a public ASN, you can use that too. Your customer gateway needs its own ASN from these same ranges. Just make sure it's different from your VGW's ASN.
What are the common mistakes people make with this setup?
Mistake number 1 is enabling dynamic routing but forgetting route propagation. I see this weekly. Everything looks configured correctly. BGP session is established, but traffic doesn't flow. Always check that propagation checkbox.
And mistake number 2?
Using static routing when you have multiple VPN connections or frequently changing on-prem networks. Static works fine for simple, stable setups. But the moment you add a second VPN connection for redundancy, or your on-prem network grows, you're creating operational overhead that BGP eliminates.
So when should I actually use static routing?
Static routing makes sense in several scenarios. Sometimes your customer gateway device doesn't support BGP, and this isn't just about older hardware. Some modern SMB-grade firewalls don't include BGP without additional licensing. Your organization might have policy restrictions against running BGP, or your managed service provider might not support it. Sometimes teams simply don't have BGP expertise and need a simpler solution. Static also works well when you have a very simple, stable network topology that genuinely never changes. And some compliance frameworks require explicit route definitions, so static gives you that control.
Let me recap what I learned. Static routing means I manually define every route, no automatic updates, and I'm responsible for keeping routes current. Dynamic routing uses BGP on port 179 to exchange routes automatically between my customer gateway and the VGW. But even with dynamic routing, I must enable route propagation on each route table that needs those learned routes.
Spot on. And here's my pro tip. Even with dynamic routing enabled, you can still add static routes to the same route table. AWS applies 2 rules in order to determine which route wins. First, the longest prefix match rule, meaning the most specific route wins. So a /24 route beats a /16 route for the same destination. Second, when you have routes with identical CIDR blocks, static routes take precedence over propagated routes. This gives you an override capability when you need it.
That's really useful for edge cases. Oh, and quick question. Can I use something other than a VGW for site-to-site VPN?
Good catch. Yes, you can also use a transit gateway instead of a VGW, which is especially useful when you're connecting multiple VPCs or have more complex network architectures. But that's a topic for another episode.
Fair enough.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone setting up site-to-site VPN connections.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.